Chapter 13, number 11. The position of a mass oscillating on a spring is given by x equals 7.8 centimeters times the cosine of 2 pi t over 0.68 seconds. What is the frequency of this motion, and when is the mass first at the position x equals minus 7.8 centimeters? So we should always sketch our situation. So we have an object that oscillates back and forth between an amplitude and minus an amplitude, back and forth like this. And they give us that this is the equation of that. We know that for simple harmonic motion, the equation should look something like the following. That is, x equals a times cosine of 2 pi little t over big T. So looking at this, we can just say by formal equivalence, the following must be true. It must be that capital A is 7.8 centimeters, and that capital T is 0.68 seconds. So this is just called formal equivalence or structural equivalence. Just by saying things equal to each other, we can identify these things. So this immediately tells us this will give us the frequency, because we know that the frequency times the period is 1. So the frequency is 1 over the period. So it's 1 over 0.68 seconds, which is 1.471 hertz. Which we have to remember is really 1.5 hertz, because we have only 2 sig figs in the thing we're using. All right, and that's part A. Part B, you can do the long and gory way. You could say, well, let me find the t such that x equals minus 7.8 centimeters. So you would say minus 7.8 centimeters equals 7.8 centimeters times cosine of 2 pi little t over 0.68 seconds. And then you could apply the inverse cosine, divide out 7.8, apply the inverse cosine, and get an answer. But I'm going to cheat at least first and do it quickly, and then maybe go back and confirm that for you. So we're going from, if we want to look at this, we're starting here, and we're going a quarter period to reach the equilibrium, and another quarter period to reach x equals minus a. So it should be 2 quarter periods or 1/2 period. So we would expect that t will equal 1/2 big T, which is 1/2 of 0.68 seconds, which is 0.34 seconds. Now I'm going to go to another board and just show that that actually works out from the trig, and we don't have to hand wave it that way. So the long and gory mathematics of it is, here's our equation for x, and we want to find the t such that x is minus 7.8 centimeters. So we just sort of plug in, and we just force it to be. We just solve this equation. To solve this equation, the first thing we'll want to do is divide out the 7.8, and that leaves us with the cosine of 2 pi little t over big T equals minus 1. Here I'm just sort of lazy and feel like writing big T and not 0.68 seconds, and we know in this problem those are the same. So the way we handle this, as always, is we want to get rid of the cosine, and the way you get rid of a cosine is by applying the inverse cosine. In so doing, we know that we end up getting rid of the cosine entirely, and we have on the left just 2 pi little t over big T. But we also know that there's only one commandment in algebra: whatever ye shall do to the one side, so ye shall do to the other side. So I have to apply the cosine inverse on the other side. Turns out that the inverse cosine of minus 1 is pi radians. And so we can see by solving this over, we can divide out 2 pi and multiply both sides by t, and we end up with that little t must equal 1/2 big T, which in our case is 0.68 seconds, which is 0.34 seconds.